Real quick, who wants a moose? Moose! Oh. Well, all right. Also have a water bottle here. This man, this little. There you go. And I will come hand these out, but I think these are USB condoms. I'm not really sure. It's just. All right, this guy, he seems really excited, so we'll go with that. All right. I'll be right up. You can stay there. Today. He really, all right. It's open to, all right. Good luck, and be safe. All right, so Sean and Michael here today to talk about optimizing threat information sharing, and with that, I'll let you guys go forward.
Sure, so this mic is hot, right? So the fact that you're in this room means one of several things. Either you thought this was Bruce's talk and you're in the wrong room, or you went to Bruce's talk and it was full so you came here, or you were looking for somewhere quiet to hang out, or you have a security clearance with the government, you were afraid of being in that room and having a discussion with your FSO on Monday morning, or you actually here to see us. So whichever of those things, we're happy you're here. Hopefully you'll find the next hour or so to be of some value to you. So we're going to be talking in our time this afternoon about operationalizing threat information sharing. So that's what we're going to be talking about. So let's start with one of the most important slides for any ShmooCon, which is the who are we. So you can make determinations of how much you want to put trust in anything we say. So my name is Sean Barnum. I'm a principal at the MITRE Corporation. I wear many hats. Primarily, I interact with international communities around standardizing how various security information is represented so that we can do things better, whether that's vulnerabilities, whether this is attack patterns, malware characterization, digital forensics. The two most relevant efforts that I lead that are for this topic are an effort called CybOX, the Cyber Observable expression, a language for cyber observables, and STIX, the structured threat information expression, which is a language for threat information, which is what we're talking about here. So that's who I am. My colleague that's going to be presenting with me is Aaron Chernin. Aaron is the security automation lead for the FS-ISAC, the Financial Services Information Sharing and Analysis Center. So this is the 4,400, 4,500 now? 4,400. 4,400 financial institutions in the U.S. This is the mechanism that they use to share information, specifically for security, but other information as well. He also leads the software development efforts at ISAC. And he wanted me to let you know that he didn't have a headshot, so he took that in his hotel room. You'll probably recognize the drapes if you're staying here. I will say, please hold your applause and shmooballs. As a caveat up front, it's likely we will be using buzzwords. Specifically because that's the focus of our talk a little bit, but also the community we work with for threat information sharing, they use the word cyber. Usually in the past when I've accidentally used the word cyber at ShmooCon last year, I got shmooballs thrown in my head. If you want to throw them, I can use them for my collection, but that's the way the community talks about things. So typically we're going to use the language that the community understands, so you might see us using buzzwords in here. So let me begin with a little bit of foundational context for what we're talking about here. So what is threat intelligence? And I'm not going to get pedantic and try and get into the formal definition on that, but want to have some common understanding of what we're talking about for the basis of so we go forward. So at a very high level, threat intelligence is an adversary-centric view of information security. So it's not just the traditional, let's look at ourselves, let's understand ourselves and pontificate our navels and think that we can identify all of our vulnerabilities, think that we can magically patch everything we find, and then voila, we're secure. That perspective is important. We want hygiene. We don't want to just ignore everything. But the reality is we do not have enough resources. We do not have the capability to defend every part of our attack surface. So if there's parts that we can't just defend by core, how do we determine where we put our efforts to block the other stuff? And you can't just do that like a hockey goalie looking at his goal. You won't know where the puck's going to go in the parts you can't block. Where do you put your arms? Where do you put your legs? And my battery is dying. That's not good. Threat intelligence is that outward perspective. Let's turn around, let's look at the adversary, let's look at who they are, how they're behaving, where they are, where they look likely to attack us, such that we can make intelligent decisions about where to block and where not. Where do we put our efforts? So at its heart, that's what threat intelligence is. Driving down a little bit deeper, it really is an, well, I'm not supposed to have built like that. It's an analysis-driven understanding of adversarial behavior, identity, intent, targeting, what the likely effects for potential victims would be, and what do we do about it. So all of this sorts of dimensions, this holistic view of this stuff, involves a lot of different types of information. It's a very broad spectrum of things you have to understand of the who's, the how's, the why's, the what's, what tools, what infrastructure, what malware are they using, who are they targeting, what does it look like, how do you do indicators of things, where have incidents occurred. It really is a holistic understanding of all of that stuff. It's important to note that intelligence is not just information, though. So all this information goes in as a source to intelligence, but intelligence is that taking the information, moving it to knowledge, understanding its context, and then most importantly, making that knowledge in a way that it supports intelligent decisions, right? That's what intelligence is about. So threat intelligence is a holistic security puzzle, understanding not only ourselves but the adversary so that good decisions can be made. That holistic picture also balances the concepts and the activities of mitigation, detection, and response. It doesn't just simply assume you can block everything. It doesn't assume that everything gets through, and it doesn't assume that you're just operations detecting things. It's a balance across that set of things. It's critical to making good decisions in security. So fundamentally, it's not just the tactical advantage of helping and understanding things like malware analysis or digital forensics or incident response or operations or those things. It is a holistic picture that ties all that stuff together with a contextual understanding of who's doing the actions, why are they doing the actions, where has it been seen. That big picture can support much more effective decisions. And it's most effective when done collaboratively. So no organization anywhere in the world of any scale, the NSA, what my colleague next door is talking about, even the NSA does not have visibility to understand everything that's going on. Every enterprise, every organization has a limited scope of what they can see and what they can understand. When done collaboratively, so it's not just threat intelligence within one organization, but when the information is being shared, everyone has a broader picture of visibility of what's going on. And if you see repetitive things being reported, you have a much higher level of context and confidence that something's real. And you can start to see who's being targeted and affected so you can interpret things more effectively. So that's going to lead into the basis of threat intelligence, what we're talking about here, but we're going to focus primarily in our talk today on threat information sharing. So the collaborative pursuit of these sorts of practices. So threat information sharing, threat intelligence has a lot of popularity and interest lately. I'm sure everybody in this room knows why and would agree with that. It's part of why you're here. Some of that's good, some of that's bad, right? It has reached full-on buzzword status. So it still has not unseated the king and queen of infosec buzzwords. So big data and cloud are still up there above it, but it's a dark horse rising fast and really becoming out there. You pretty much see every analyst and research firm now issuing studies and reports and articles on threat intelligence, threat information sharing. And that's not just the companies that do threat intelligence analysis and they're saying, here's this campaign or those kind of things. These are players writing reports on the fact that you can write reports, right? So analyst firms and things like that. And that's not always a bad thing. Some of that stuff's good. It's good to have the awareness out there. If you're pursuing this stuff and you look at good sources, it's going to help you understand this better. But anytime you have movement in an area, you also have the poser sweep in, right? So you start to have players that are talking about to the uninformed, oh, it looks like they're, these are equivalent. But the reality is a knowledgeable source looking in is going to understand that under the covers, some of that stuff's gibberish. Some of the people talking about this stuff really don't understand what they're talking about. So it's important to actually differentiate and look at the experience of who's presenting and talking about things to understand whether it's something that's worthwhile or not. Every vendor out there is also moving in this space. There are lots of great solutions being done by engineering to support threat intelligence, to support threat information sharing. But similarly, anytime you start to see threat intelligence and stuff come into marketing, you need to ask yourself, did it get put there by the marketing group or by the engineering group? And if it's the engineering group, it's probably a decent thing. If it came from the marketing group, it's fluff, right? So you'll see, do we really have to talk about vulnerability scanners that have been around for a long time, now being referred to as vulnerability intelligence tools, just to throw the word intelligence in there? And that, on the RSA floor, I saw 2 different vendors actually do that. I also saw a static source code analysis vendor talking about software intelligence. So, I mean, again, there's some good capabilities coming out of the vendor space, but there's also a lot of hype and a lot of buzzword crap that you want to ignore. Every sessions, and of course, that's not a bad thing. It got us on the stage and it got us our badges, right? So, hey, that's good. So, thank you, ShmooCon Program Committee. But you'll also see some of the stuff that in a stretch goal to try and get that in, sometimes you will get speakers who maybe not understand it all that well, or you'll get the architecture parts that you don't want. Similarly, going beyond even the technical space and the security space, you start to see the media talking heads talking about threat intelligence and threat information sharing, right? Network news programs are talking about this stuff. Non-technical magazine articles and bloggers and stuff. So again, this is good from an awareness perspective, letting people know that this stuff's important, but you also get a lot of people talking about things that have no clue what they're talking about. I get phone calls from my parents who are Luddites on the West Coast going, hey, I just saw this on the news. They have no idea what they're talking about, right? So it's important to understand the value point there. And then we even see this sort of stuff being talked about not just once or twice, but on an ongoing basis from the highest orders of government, right? So the White House talking about this stuff, or Congress talking about these things. So there's a lot of popularity, interest, but there's also a lot of hype. So it's important to try and differentiate between those when we think about this stuff. That sort of interest and activity is also moving to a lot of policy activity. So we moved past the days when the people who were the security guys in the trenches who actually do this stuff and have been doing it for a while on their own, ad hoc within their organizations, they've been doing intelligence, and they've been trying to talk to their senior management that, hey, you know, we need to integrate the various parts of what we're doing here so that incident response actually talks to operations in an effective way. And you know what? We need to share with some trusted partners. We moved past the stage where a lot of that has to happen and you have to convince people, to the senior levels are now understanding this. So you see some policy coming out, whether that's in the commercial space, a lot of the verticals, so the financial sector, national health sector, electrical sector, Ben, shout out, ICS, telecom, IT, these different places are now, large organizations are actually defining policy to do this stuff. You're seeing intra-government policy. So if you're familiar with the CNCI 5, the Comprehensive National Cybersecurity Initiative, Part 5, basically says, hey, that actually deal with this kind of things, you should probably be talking to each other, right? So defense should be talking to DHS, that should be talking to law enforcement. And so there's some policy coming around those things happening. There's intra-government policy happening from an international perspective. In the EU for European nations, how they're going to share. There's allies. There's all kinds of different things going on at that level. There's legislative activity. You're seeing things out of the Hill, right? So CISPA that came out was how people can do this. Now, there's issues with how that was done. It was thrown together relatively quickly and maybe did not provide appropriate levels of concern for privacy and some other issues, or at least how they talk about it was not done very well. But you'll see those sorts of policies coming out in the legislature, and you're even seeing it out of the White House too, right? So the PPD 21, the National Strategy for Information Sharing and Security, these sorts of things from a national level saying, hey, we need to think about this. So there's statements coming out of saying, this is important and thou shalt go do it. So that's important to have that top cover from a funding perspective, from a support, those sorts of things. But the reality is policy alone doesn't get you there, right? The real world's a little more challenging. So the real world, to do real operational threat intelligence and information sharing, is more than just policy. There's lots of different dimensions of challenges. There's technical challenges. So how do we actually talk about the things we want to talk about? How do we process that? How do we analyze that? How do we store it? How do we exchange it? There's issues with automation, so how do we automate handling of this stuff, automate analysis, these sorts of things. There are information sensitivity challenges. So the privacy issue that I was just talking about is one, but there's others, right? There's classification issues with government. There's sensitivity within even certain commercial spaces of how much do I want to tell you about something because I might be exposing something that I don't want to. There's human challenges. People that understand this stuff are in very short supply to try and do this, and the scale and scope of information we're dealing with is massive. So there's challenges around how you actually get the right people, the right things. There's trust challenges. This is fundamental. So anytime you're dealing with sharing, you're talking about you actually, what are you going to share with who? Because it's not just a binary decision. I'm going to share something with you and maybe something else, and how much do I trust the stuff that's coming back from you? Do I really put high trust in it and act on it immediately? Do I do extra activity? So there's challenges around that. There's policy conflict challenges. Shocking, right? So all these policies are going on. They don't all align, especially in the international sphere. So if you're dealing with intersections of policy, how do you work that out? How do you actually deal with multiple policies in different contexts and stuff? So the nice thing is there is a lot of activity also to try and start to make this stuff operational, practical, real, right? So you see scores of different communities, vertical ISACs like I talked about, and Aaron, my colleague here, is going to be talking with us briefly here about what the financial community is doing. But you're also seeing regional communities, right? So in the Northeast, in the West, in Seattle area has got the SWIFT stuff, there's the PRISM stuff, there's lots of different regional stuff, there's intergovernment communities, there's intergovernment communities. There's also various efforts to try and make this stuff more practical. So one of those, just the one that I lead, a community effort called STIX, is probably the largest and widest spread, involving hundreds of organizations in all different areas, but there are others. So STIX is an international community of players. MITRE plays, my role and MITRE's role is as a coordinator among those things, and our role is sponsored by DHS. It involves lots of players trying to say, okay, well, if all these organizations are trying to share this information, how do we make that better? How do we actually structure the ways to talk about that so that automation can be applied, so that consistency is there, so trust models can be built appropriately? So there's things like that. And then there's a lot of activity, like I said, in the vendor space. I can tell you there are almost every security vendor you're going to think of is looking to try and either integrate what they do into the broader picture or are looking to extend what they do into this space and understanding things, or new companies and some of the bigger companies are really looking to do whole new solution levels that integrate this stuff into things like active cyber defense and things like that. So there is a lot of good progress being made. There's a lot of activity that we can learn from, but I'm going to hand it over to my colleague and let him talk a little bit about what the financial community is doing right now.
Sean, did you save me any battery? Do I have battery?
I think it should be okay.
All right, great.
I hope so.
So I'm Aaron Chernin, and I work for the Depository Trust and Clearing Corporation, and I lead the security automation team, where we focus on automating a lot of the manual tasks that we do in information security today. I also wear another hat, the FS-ISAC. I chair the Security Automation Working Group there. So the FS-ISAC, large acronym, Financial Services Information Sharing and Analysis Center. Think of us as thousands of banks that all compete against each other. We need a neutral ground to come together to talk about the common threats that attack us. And that's nearly 4,400 members, and we represent a majority of the financial sector. And within it, we have the Security Automation Working Group that I chair. And just be forewarned, we don't just talk about the way things should be. We don't just talk about how to fix them for months on end. We write software and we fix it. But before we can write software, we have to build a business case. And there's a number of business case on risk reduction, right? So if we do things faster, we reduce risk. But sometimes they write dollar signs around it. So the business case that I'm showing here is one that we built based around automation. So what I did is I sent a survey out to the 4,400 members, and I asked them about the key points of cyber intelligence processing they did and how long it took. So how long did it take to extract? How long did it take to write the email or put it in Excel? How often do you check your inbox every day for someone telling you something? How long to read that from your inbox and get it out of Excel and then get it into your tools? So an average throughout the industry, it was approximately 7 hours per indicator. That's pretty high. So if we take CISP, which is one of the intelligence sources we use, and it's just one of them, and we take all the indicators that we receive from CISP, and we multiply that by 7 hours and also by the average cost of a threat intelligence analyst, we end up at approximately $10 million per financial institution to manually integrate this data. And you know, with most Intel feeds, to keep up to date with that would be approximately $35,000 a day in man hours. And that's just one source. So we're not doing anything, right? So on average, we're ignoring over half of the intelligence that we receive. If you look at how folks answered, how many people are dedicated within their environment per FI or financial institution processing cyber intel, and you can only do 1 hours, that's about 1 indicator a day. So it's likely less than 2% of the intelligence we receive we actually act upon. So the real problem we found isn't that we don't get enough intel, and the real problem isn't that the intel isn't good enough. The problem is we have intel, where we have threat intelligence analysts doing the jobs of machines, right? So we have threat intel analysts converting data from one format to another. We've got threat intel analysts copying from one tool to another instead of doing analysis. So why don't we let the machines do the machine work, and we'll free up time for threat analysts to do analysis work. So how do we make machines talk to machines? I mean, this is a problem that we solved, I don't know, tens of years ago, right? To make machines talk to machines, we use standards, right? We need predictable formatted data so the machine can act upon it when it receives it. The structure that we picked was STIX, or the Structured Threat Information Expression, and it's primarily XML, but you could do it in JSON or however you like. The great thing about STIX is it allows us to talk about and campaigns and TTPs. It's not just focused on incidents or indicators. And to get this intelligence data from point A to point B, we need a method to move it. And that's where taxi comes, which is another standard, so the trusted automated exchange of indicator information. And it's a RESTful interface that, think of it, allows us to push and pull intelligence from remote sources. We built a repository to try to start implementing some of this automation. Looking at the technology stack from the top down, Bootstrap, Django, Python, MongoDB. So making a repository product, we had to come to some to terms with some things. One of them being is we're building a community. And the more people that use the community, the more successful and safer we will be. So if we charged for the software, we would actually become less safe because we want as many people to use it as possible. So the first thing we came to terms with was we have to give it away for free. The next thing that we did is we had our vision laser targeted on certain things. So if you see other people in the threat intel space, they're kind of shotgun approach all over the map on what they're going to fix. We are only getting from point A to point B, and we are only getting data into our information security tooling. We are not creating intel. We are just the plumbing. We are the routers. We are the web servers. We're not making intel. So to get the data to the tooling, what we do is we allow you to create feeds. And once you've created a feed within the system, it's really a taxi feed you've created, you can download a sample Python script and use that Python script to pull your feed. And it uses libtaxi, and it's great because you can reverse engineer it and figure out how to use libtaxi. It also has some really good example DOM parsing for parsing really, really complex DOM trees if you guys aren't familiar with doing it. And this isn't the most optimal thing to do forever, right? So we want to cater to the most common denominator. Not everyone's a Python developer. But this is how we're starting, and in the future we'd like to mask this through software. So what are we using the repository for? Like, what kind of data are we sending to it? So, well, first off, we're the evil banksters. And so we're looking at your grocery receipts. Absolutely not. This is cyber intelligence data. It's malicious file hashes. It's domains. It's URLs that are serving up malware. At more complex levels, it's malware analysis, full analysis. Or maybe you've had a threat analyst that's analyzed an attack from one end of the kill chain to the other. That's the type of data that we're sending through here. Next is the users quality rate the data. So if you've got someone on data as high confidence, but it's coming up with a lot of false positives, folks can quality rate that data down, and it bumps off of their feeds. And we also share, you folks may be involved in citing information today and not realize it yourself, but think of it this way. When you send something to a mailing list and you say, I saw it scanning one of my apps, and then you have 45 people respond and go, +1, +1, we saw it too. You know, that's a citing. Well, most of us received, I don't know, 10, 15, 20, 30 different Intel feeds, open source, vendor purchased, and they're all in different formats, right? So this is one feed of all that data, consolidated, reconciled, deduped, all in the same format, so machines can act upon it automatically. It's beautiful, machines talking to machines. The only screenshot I'll show. What I thought was interesting when I took the screenshot is on the day that I took it, we had, this is our integration server where we practice integrating with new Intel sources. And on this day, we hit 48,000 indicators through the system. So just, this is our bootstrappy top. The future. We've been focusing on indicators and observables. We want to move towards attribution sharing so we can talk about campaigns. We want to move away from a hub and spoke model that we are today into a more federated model that uses local installations with repository to repository communication. And then we're going to have to add some analyst workbench type functionality because it'll make it easier for us to get data into the system if we can extract it directly from the malicious tools. And finally, it's about the community. You could build the perfect sharing platform for cyber intelligence, but if you do not have the community behind you, you won't have any data going over it. Your plumbing will be empty. So this is what's really important about the ISAC model. If you're a part of an industry with an ISAC, please join up and share intel with them. Thank you.
So for the rest of our time that we have here, we're going to try and go through kind of briefly, very shallow on each one, but some high-level lessons learned out of the activities the FS-ISAC's been doing among the different financial institutions, as well as some similar lessons learned out of many of the other members of the communities that we're dealing with and talking with, some of the stuff that's happening in some of the other verticals, some of the stuff that's happening in government things. So some really higher level, we're not going to go too far down any technical holes, but if you are looking to try and stand up a capability for threat intelligence, if you are currently in your organization doing threat intelligence and you're looking to do more sharing with other, join different communities and stuff, hopefully some of these, again, they're high level, more principle level stuff, but these will be things that you should keep in mind because these are the results of various other parties doing what you're doing right now, going down lots of dead ends, and some of the really important stuff to focus on that they learn. So we're going to kind of bounce back and forth a little bit and talk about some of these. So the first one that's pretty fundamental here is that structure is important. So structure of information is important. Human language, kind of the state of the practice in most places right now, or the kind of thing that Aaron was talking about, where it's an analyst in one organization emailing another analyst somewhere else and saying, hey, I saw something like this. And while that's great for that one thing between those two players, that absolutely does not scale. It doesn't scale within any one enterprise with all the stuff you're processing and dealing with, and it really doesn't scale when you start to share with other parties because now it's not just what you know, it's all the stuff they know being shared in. There's the diversity of what does that human language prose look like when you're talking with this party versus that party. So it doesn't scale, it doesn't give you any sort of consistency. So structure of the information so that you can align semantics, you can align terminologies, and that you can actually move to automated exchange, automated processing of this stuff, automated conversion of the things and deployment into tools is very important. So the first really fundamental lesson of all this stuff is you can't solve the of this issue. So the cost differences that Aaron was talking about from a processing of how much stuff goes through, until you can structure it, you can't apply automation. If you can't apply automation, you're really just kind of scratching on something that's much bigger than what you can get to. So that's kind of the
So before we could start writing software on using standards-based method to get data from point A to point B, we kind of wanted to look and see what was already out there. We learned a lot about standards, and we knew that we didn't want to create something. We wanted to probably join a community. It would be easier to get folks to adopt if we didn't make it. So a number of things that we noticed was there's some standards that compete with STIX, and there's some that are complementary to STIX. And I'll give you an example of a complementary one, because some folks may think it's a competing one. The Mandiant OpenIOC does not compete with STIX. Think of it as the host-based checking side. So you would use STIX to get it from point A to point B, and then convert it over to IOC on the host base to do your scanning. Also, when folks are talking about making a standard, you've got modern day standards and you've got old standards, and you can kind of see how they evolve over time. STIX is very modern. You can tell it's modern because of some of the functionality it has. You can do things like not have to use a specific format. For example, you can use XML or JSON if you can get it to meet the STIX requirements. Also, it's got logical operations, so you can do lots of anding and oring throughout your documents. You can create composite documents. You can do inline or referencing of your data within the document. These are all what we would consider modern day standards versus some of the other others that have been out there for 5, 10 years.
So the next one is semantics matter. So if you're going to actually talk about structuring information, it's more than just a format of something saying, oh, well, okay, well, when we're going to talk about a file size, it's going to look like this. That's important. You have to do that for consistency. But for this stuff to be effective, especially given the nature of all the different ways this can be done, You have to think above simply the format of one thing. Languages these sorts of structures are much more effective when they're higher level languages that are more flexible, so that they deal with not only the specific formats, but they deal with the semantics, ontology, taxonomy, these sorts of things, so that you can understand not just, oh, when you talk about an apple, here's what you say, but what is an apple, and what does an apple mean, and how does that relate to the bigger bowl of fruit? And so representations for structuring this information are much more effective when they actually consider everything from the lowest level representation, which you absolutely have to have for automation, because machines can only understand it when you've specified it, but for people to understand how they're going to do this and deal with it, and when they generate stuff, when they consume stuff, those other levels are equally important. So you have to actually have some commonality for semantics in those other levels as well. So it's really a balance across that entire stack of abstraction that is most effective when you're actually talking about structure for these things.
I can tell you that you're going to want to use a schemaless data because I did it wrong first. So our first few attempts at this, we went back to our SQL roots and went to town. We went quickly into mapping hell, taking STIX content and mapping it to tables with hundreds of columns. So go straight to schemaless, do not pass go. Your documents just fall into it. If you're going to go schemaless, I would recommend databases that do have a JSON backend. That's one of the reasons why we did Mongo, but there's also Elasticsearch and others that are very similar in that matter.
Yeah, just to add a little bit of comment there too. So there are some organizations that structured SQL type stuff is going to be important because they're dealing with less sophisticated data, less complex, and then efficiency and speed is important. But the nature of threat intelligence varies so greatly on the granularity of what you're talking about. You might just be talking about a file hash, but you might be talking about the file. You might be talking about the file and how it relates to an email. You might be talking about that email using it. There's so much granularity of things that it becomes difficult to do in a tabular fashion. So that's the lesson learned here, is not that you must always do this, but the experience that FS-ISAC had has been mirrored in many other players where they did start to do it one way and they found that it was most effective for them to do it the other way. So this is not a hard and fast rule from you, but just something you might want to take as input when you're looking to actually do this. So the next one is threat intelligence is heterogeneous. So like I just said, the granularity of the information, but not only the granularity, okay, well, what kind of information is it? Is it about campaigns? Is it about indicators, about incidents? As well as who are the players you're actually interacting with? That's inside your organization. So this is information that comes from your operations group, your SOC, your CERT. This is information that comes from your, if there's people doing campaign analysis and attribution analysis, this is stuff from the people who are doing detection with indicators and stuff. So there's different parties and players within an organization, and then especially when you start to share among multiple organizations. So one way of sharing is something like you're hearing with the FS-ISAC model where, oh, these are all FI sharing. So there's some common context, but the banks that are sharing within FS-ISAC are also cross-sharing with other organizations. People in the IT space, General Electric and Microsoft, and people in the electrical space and stuff. The context varies so greatly that it is important when you start to talk about the processes, the structures that you're actually dealing with threat intelligence, to recognize you can't force everyone to play one way. So it's important that flexibility be a first-order design consideration. So as you're doing this stuff, recognize that you're not going to be able to do one hard, fast, exactly this is what it looks like, and everybody's going to do that, because they simply won't. Especially when you're dealing with certain concepts and terms, there may be different communities have different needs for vocabularies on those terms. Maybe there's a shared basis, but each community has a little bit extra. And you don't want to have the electricity sector having to deal with some of the terminology that's only specific to finance, right? So design for flexibility is an absolutely a key constraint if this is going to be useful, if this is going to be applicable to players that you're going to actually be working with. And that's you.
STIX is big. It's very wide. If you try to implement the entire thing right out the get-go, you're going to get annoyed. So I kind of took a different approach, and it's a typical project approach. So instead of building something really big and having one win at the end, split your STIX adoption up into phases and phase your way through it. You could probably do 10 to 20 phases of your adoption of STIX. And what's nice about this is it's easy to do. You can have a nice scope on each phase, and you get wins all the way down. So instead of a single win at the end, you can have a dozen wins as you do your adoption. And you can adopt various discrete components of STIX and still use it. A really, really good way to start is just to say, you know what, I'm only going to do indicators and observables in STIX. And then later on, maybe I'll move to TTP. Or you could scope it down even further and say, maybe I'm going to adopt these certain observable types. I'm only going to share file objects. I'm only going to talk about files over STIX. STIX is so documented and structured that you can make these types of decisions.
You might be the next one as well. So yeah, and that's not just STIX adoption. This is just in general, right? There's so many different types and parts of threat intelligence that simply saying going in, we don't do it, now we're going to do everything, is a recipe for failure. So really just pick individual pieces. Get your SOC and your incident response guys talking to each other and sharing information. And then work to, start small, work it together, and build from there. I think yes, this is you too.
So one of the things we did to reduce inertia, I said earlier, was to give it away for free, right? But there are other things that you can do as well. We can't tell everyone to go ahead and do a taxi poll. And they have no idea what you're talking about, and they have no idea to do it. So another way we got around that was providing sample Python scripts so people could do a taxi poll. Next is, if you see what other folks are doing in the space, it usually, I'll give an example if any of you guys have messed with something called crits. There's like, I don't know, 3 or 4 pages worth of commands that you need to install to get it up and running. It should be as easy to run it as starting up a VM and going to it with your browser. That type of stuff really makes it easier to get the end user on board and online and contributing intelligence. One other thing that we had to do that is kind of stressing is give people a limp mode way of contributing data. So if you have no way to create STIX, unfortunately allow them to provide CSVs. The way that I feel good when I go home so I don't have to shower afterwards is by converting the STIX, the CSV file, to STIX before it goes into our system. So their data eventually becomes STIX, but it's, it's flat CSV, and it's a limp mode. And our hope is that we can someday remove the CSV functionality from the system.
So just add a little more there too. So when you're dealing with centralized and thinking about the structured way of doing this stuff, the reality, fitting back to some of the previous lessons learned, that at the heterogeneity, different players today are doing some of this stuff, but they're not necessarily doing it in a consistent way. So as Aaron was saying, it's important to don't say, okay, if you're going to be part of the game, first you have to be a professional player, right? Start working with the players who are out there at the level they're at, find ways to bring them in, find ways that they can continue doing what they're doing, but just a little bit better, and then a little bit better, and a little bit better, and eventually bring them onto the team where they're actually working full scope. So this and the previous one of starting small and building go together. How do you actually get people into the game, working through this stuff, and how do you build them and mature them? And when I say people, this is not just individuals, this is organizations, this is communities as well that are working through these things. So the next one is, I'm going to butcher this, the Russian proverb, "Dovrye na provye," which is trust but verify. So this is the saying that was made popular in the 80s by Reagan, at least with the US. The Russians have known it for a long time. But trust is an absolute fundamental element, arguably the most fundamental element in information sharing. So if you're going to be sharing with other parties, it's important to understand, number one, that simply saying I share does not mean I share everything I know. It does not mean I share everything I know with everyone. It does not mean I share everything I know with any one party. You have to understand who are you going to share with. You need to determine what your level of trust in those players are. I mean, obviously, if you don't trust somebody at all, they're probably not going to make that initial list. But determine what sorts of information is important for you to share out with them. This might be the fact of how much do you share. Most organizations, when you're dealing with threat information, your really secret sauce, the stuff that's really important, the broader that gets shared, the less value it typically has, because the more likely it's going to leak to the bad guys that you know what they're doing. So there's always this balancing act between, okay, well, how much do you share and what do you share and how, but trust is an absolute key piece of this so that you understand both what you're going to share out to other players, and it's equally important with saying what are you going to actually take in. So not only, hey, this is what I'm going to expose to here, here, and here, but as you get information and you get intelligence in from your sharing partners, the people that you share it out with, what level of trust do you put in that? So there are some players that you might know the people who are doing the work. In fact, in the communities that we interact with, we hear all sorts of anecdotal stories. And there's stories of, communities where, hey, this organization over there, they usually generate really good stuff. We like their stuff, except for Joe. Joe populates a lot of stuff on the list, but whenever it comes in, we just trash can that stuff because Joe doesn't, So that sort of thing goes on today. But it's important when you're starting this that you understand that trust is not simply a homogenous view. You really have to understand the different dimensions of this, who you're going to trust. Stuff that comes in from one party, does it require an extra level of review? Does it require an extra level of analysis? Or is this stuff, because of the nature of what's being shared and how much you trust those players, is it possible in an automated fashion to take an indicator in from a partner you highly trust and in automatic fashion at machine speed deploy that to your sensors? Or an action to your infrastructure that's going to actually take course of action for blocking and things. So fundamental to information sharing, not just in threat, but is this dimension of trust, and it's very important that this be thought about. It's not simply a technical challenge. It goes beyond that. Next one is threat intelligence sharing is a lot like the lottery. The more players that play, the bigger the rewards. So this is important for that reducing inertia, that your value that you get out of sharing is going to go up not in a linear fashion, but in higher than a linear fashion with the more parties that are sharing if they are sharing effective information. So the fact that I see my scope of understanding of situational awareness and what I can see going on, if you and I start sharing, now we have the union of those two scopes. We can see a little bit more. And as a third party gets added, we not only expand that union of scope of situational awareness, but the more parties that come in, it's not just the visibility boundary that moves out as you see more stuff, but you start to see duplication, which sounds like a bad thing at first, but if you're seeing the same thing being reported from multiple parties, you can use that for confidence, right? It's not just, hey, this one party's out there. Are they really seeing what they're saying they're seeing? Oh, as Aaron was talking about sightings, this stuff's being seen in lots of places. My confidence that it's real, number one, goes up. My confidence in the interpretation of what it means goes up if multiple parties have the same interpretation. And, you also have the ability to be able to detect things like who's being targeted. So if you're seeing among your community of 1,000 organizations that are sharing, or in the case of FS-ISAC, 4,400 organizations, okay, well, it's being reported by these 12 organizations out of that. What do those 12 organizations have in common, right? Is this a campaign going on targeting a specific kind of information? If it's those 12, who else would fit within that space that should know about this and really be taking advantage of this stuff? So the value of the network of sharing is going up with Metcalfe's law as the number of players actually grow here.
So I don't know everything about intel sharing, and neither does Sean. And so one of the things that is an irritant is when we're discussing in forums like the STIX mailing list, and we're debating STIX functionality, watching folks jump in and say, we're just going to continue doing it this way because MITRE said so, and they made STIX. So none of us are right. If you think we're wrong, tell us, show us a better way. The next thing that I'd like to say is, if you're trying to fix the cyber intel sharing issue, it's going to be more than just kind of fixing the problem we have today, right? So there's not enough fields we can add to a CSV. There's not enough PDF docs that we can send that'll fix this problem. And then finally, if folks have to write XML to do this, we will fail. I truly believe that if I have threat analysts writing XML, we're going to fail, right? And so I kind of feel that's where we went wrong with other standards as well. We've relied on the end user of the standard to actually create the data. And I want to ask the group, we've got millions of people that surf the internet every day without understanding the line of CSS. How many of our network admins at our organizations are hand building all the TCP packets that go over our networks, right? So we should be building systems that make STIX transparent to the threat analyst and not editing the XML. That's me. Yep.
So yeah, so that sort of visionary, don't just solve today's tactical problem, think beyond it, goes for the structure, like Aaron was saying, right? So don't just say, oh, we have these fields in a CSV, how do we represent them in the format and move? That's important, but as you look to solve those tactical problems, be thinking beyond that of where you want to grow to. So both from a structure perspective, as Aaron was saying, for them, they also want to represent, campaigns and stuff. So think beyond simply how you automate what you do today. Solve a tactical problem within a strategic context. Similarly, with the capabilities you're actually deriving out of these things, don't simply say, okay, well, what are our people doing today? You need to make that easier for them, but understand that once you make that easier for them, once you automate some of the things that they're spending all their time doing today, and they have the cycles to do the more important stuff, well, what are they going to be doing next? What are the things they're not doing today because they simply don't have time to do, or they don't have the capability to do because the information's not there? So as you're designing what you're trying to do, think not only for today's problem, but think about once you solve that, what is it going to make it possible tomorrow, and solve today's problem in a way that actually supports tomorrow as well.
If you don't say it, I can guarantee that STIX won't be able to do it. So if there's some specific functionality that you need, and STIX doesn't do it, then speak up so we can get it in there. Also, there are people who work as standards evangelists full-time. They don't do cyber intelligence. They don't write software. I don't even know if they're fixing problems, but they're evangelizing standards, and they're setting a perception. And if this perception wins and we lose STIX because of it, we'll be left in limp mode. But you know what? Standards bodies will be happy. So what we need to do is be vocal. Talk about our success stories. Talk about, that you were able to share some intel with STIX and you found these things in your environment because of it. We can fight perception with reality, right? And as customers, we can help with STIX adoption by demanding our vendors implement it before we purchase. Speak with our pocketbooks.
So really the general here with Be Vocal is the fact that value for this space, just like value if you're trying to do your own threat intelligence in your organization, you get value from sharing. Here, how do we actually, as a community, all the verticals, all the government, everybody, solving this same problem, it's the reason we're here today, is how do we actually, we're giving you hopefully some of the stuff that's been learned from these things, but the value of that overall community, the rising the tide to float all boats, is driven by discourse among the community. So this is not simply individual players going off and doing this stuff and saying, here's the right way. The value of this stuff is going to be by the diversity of sets of voices that are actually speaking into what is your problem, how are you solving it today, where are you seeing value, where are you seeing challenges, these sorts of things. It's that overall discourse that's actually going to make this possible to move as a whole community to higher levels. So being vocal, speaking out, become part of the conversation is key here. So just wrapping it up kind of for a conclusion for us, really, first of all, it is possible to move beyond policies and buzzwords. While that is absolutely something that's out there, it is possible to do this stuff real world, to operationalize it, to actually see positive benefit from doing these things. It's just important that you understand how to differentiate between the buzzwords. It's important that we take policy for what it is, the important stuff from an awareness perspective, but that we recognize what the other dimensions of challenges are, learn from each other to actually resolve those challenges to move forward. So the practitioner community doing this stuff, organizations like FS-ISAC, other communities, other companies, government entities, they are growing and maturing quickly in this capability, in this space. And one of the interesting things is from a STIX perspective, when we're trying to model the information, part of our challenge is not only to model all the information that's in the space, which is broad, but the reality is the space itself is still moving and emerging. No one has really figured out fully what threat intelligence means. So as it changes and we evolve, and as the practitioner community grows and stuff, it would behoove you, if you are part of that community and you're trying to pursue this, to try to listen and talk with others and learn from what they've done and take those lessons learned to heart and put them into play with what you're doing. And better yet, rather than just listening to other people, really become part of the community. Speak your voice in, don't just be a lurker, don't just listen to what other people have to say. So it'll be better for everyone listening to all that hype that's going on out there. They'll be able to separate real from fake crap faster if the people who actually do this stuff are speaking together in discourse, because then they can start to understand the differential. It's not just one party versus another. They can see who's talking as a whole and where there's agreement, where there's consensus, and where there's maturity moving forward. So that's what we had for you today. I don't know if we have a couple more minutes or anything to answer questions. If not now, we have 2 minutes or 3 minutes. Does anybody have any questions? We're happy to take some. Go ahead.
You mentioned that taxi is free. Is that because
Yes. So for STIX and taxi, those two pieces we're talking here, STIX is a language, so it's fully open to everyone. There's GitHub sites where you can get the schemas. There's a website you can get the latest releases. There's also a whole set of utilities that go with them. There's standard practices, suggested practice guidance, that kind of thing. Taxi is a set of specifications for how you could implement technology to exchange things back and forth. So if you build the technology, those specs, they will work regardless if you built it or if I did. Along with that, similar to STIX, where there's some utilities and code base, there's also some utilities that Aaron mentioned, libtaxi. We didn't give the explanation of what that meant, but there are some tools that actually are open source available. You can download and use however you want. So all of this stuff is free and open to everybody to consume and to use however you want. Even the utilities that we provide for the STIX stuff and these things, they are by no means intended to be products. They're simply utilities that let people start to think about and use this stuff and figure out what they want. Product vendors can listen to what they've learned and build things. Product vendors are free to take the code that's out there for utilities and build actual commercial products on top if they want to. Doesn't matter to us. We just want to have the community work as a whole to move forward. Does that answer your question?
Yeah, I won't use the commercial stuff.
Absolutely. Absolutely. Sure. Do you want to speak to that one? Sure. I'll let the yeah, if you can repeat the question too.
Oh, I got that shock that you got earlier.
You heard that.
So I guess was the question, can we give some examples of integration using STIX data that's been shared to them? I can't talk about any incidents or events that have occurred, but I could tell you that folks are taking STIX data that they've received from the FS-ISAC, converting it into things like snort rules, Mandy and OpenIOC signatures. They're pushing it into their QRadar SIMs. Some folks are creating Splunk reports out of the data. It's with the Python script we give folks, you just need to be a modest Python developer to be able to take that data and convert it into some other proprietary format.
One other simple example of that stuff is, so you consider the phishing use case. You forward something that's suspicious or whatever. There's utilities that people are using now that can take the emails that come into suspicious whatever and can automatically transform and build the full structured representation of the email, all embedded URLs, all attached files. The URLs derive out the domains, do whois lookups and capture that, do DNS queries and capture, so that the poor sap that comes in every day and looks at that has the first 12 steps they're going to do automatically done. So there's lots of examples like that of different organizations doing that. I think maybe we have one last. Nope. I just got told I'm done. So we're happy to answer questions offline if anybody has anything. I wanted to be able to at least take a few questions, which we did too.